Okay, this is a video for Objective 41 in your money textbook. So again, if you don't have your money textbook, hit pause, go grab your money textbook, and you're going to turn to page 77, which is the first problem of Objective 41. I think there's going to be 6 problems again here. We'll run through those and then explain what's next in the workbook and for your test. So Objective 41 is called Solve a Problem Involving Inflation. Inflation basically just means general increase in prices over time, meaning as time goes on, different items just generally cost more than they did. Basically, if you take a look at 1950 to now, almost everything now costs more. Loaf of bread, gallon of milk, cars, houses, prices just go up. So a lot of these are going to involve percent type problems. We're going to use some different ideas that we've already used in some of the other objectives to solve these type of problems. So let's take a look at the first one, number 25. It says between February 1995 and February 2010, inflation caused prices to increase by approximately 43.6%. So it says about how much would Mr. Yadin need to spend in February 2010 to buy the same products he bought for $700 in 1995. Okay, so in 1995, if you bought things for $700, we're now wondering what would that cost in 2010. So get this going here. It says so we started with 700. It was increased by 43.6%. So this is basically like a tax or tip problem where we start with a certain amount of money. We're going to take a percentage of that and add it to the original. So we start with $700. We're going to take 43.6% of 700. So we need to change this to a decimal. So we go 1, 2. So we have 0.436 times 700. Order operations say we multiply that first, and we get $305.20. We add it to the original 700, and here's our answer: $1,005.20. Okay. Number 26. This is going to go back to an idea we did, I believe, in end of second or beginning of third quarter. It says Mr. Echo Hawk bought some items that cost $300 in October 2003. Due to inflation, these same items cost $351 in October 2008. So by what percent did the prices increase? So this is a percent change problem. So percent increase or decrease. So I put this formula. This is something we did earlier this year. Okay, if you're looking for a percent increase or decrease, okay, you set up a fraction. The amount of the change goes up on top. The original amount goes on the bottom. So those are the two key things. So the top number, we take how much it changed. And we just do bigger minus smaller. So it ended up at 351. It started at 300. Subtract, that's a $51 change. Then the bottom number is key, that you have the correct number there. The original amount, since this is a problem that's based in time, October 2003 is before October 2008, so it was $300 first, and then it raised to 351. So the original is $300. So we take 51 over 300. We divide that. We're going to get a decimal, and our answer that we get there is the percent as a decimal. So now we just convert, move that 2 to the right, and that's a 17% increase. That's letter B. Okay. Number 27 says each year a company makes a 3-year prediction of the average annual inflation rate. In January 2010, a company predicted that an annual inflation rate of 4%. If an item cost $90 in 2010, how much would the item cost in January 2013 based on the predicted inflation rate? Use the table to calculate the answer. So I'm going to show what the work I showed here is the way that they kind of lead us to doing it with a table. And then I'll also just show you a second way that you could do this problem based on something we learned just a couple objectives ago. So if we look at this problem, it is like a compound interest problem because each year you're going to start with a new amount. Okay, so in 2010 it starts with 90. The inflation rate is 4%. So here's the work. Okay, start with $90. 4% of 90 is $3.60. I add that to the original 90. So at the end of year one, we end with $93.60, which I put right here. That means now the next year, we start with that amount. We don't start with 90 again. So we start with the 93.60. We have to take 4% of that 93.60, which is $3.74 rounded. I add it to what we started with that year, the 93.60, and we end up that year with $97.34, which is right here. Then we do it again because it wants 3 years. So we start 2012 with that 97.34. We take 4% of that. It's about $3.89. So you see it's going to grow a little bit each year and how much you're earning. We add that to what we started with at the beginning of the year. So $3.89 plus the $97.34, and we end up with $101.23. Now, just because I rounded each time, it ended up being just a little less than what, but we look at the choices here. The best choice is letter C. And if I didn't round any of the choices above, it would have came out to be 0.24 or something. The other way, and that's just do it that way if that way makes the best sense to you. The way you could do this is we looked at a formula for compound interest when compounded annually. Okay, so that formula, and this was a few objectives ago, looked like this. The capital B stands for balance. The P stands for principal. The R is the interest rate, and the N was the years compounded. So the principal would be 90. I'm going to do 2 steps in one here. So the interest rate is 4%, so 0.04. I'm going to add the 1. So we would have 1.04 here. Okay, and this was for 3 years. Okay, so order of operations says we have to do the exponent first. So you take your calculator, remember that x to the y button, so you hit 1.04 to the 3rd power, and it gives you something 1.124, and if you don't round it, it'll be even a closer answer. So we have that, and then just leave that answer in your calculator, hit times 90, and I end up getting 101.23776. And again, that would round to 24 cents. Okay, so that's just another way you could do this problem. You don't have to use the table that they gave you here. So 2 ways to do that problem. Okay, so if you want to look at that, you can pause it, look at that, play it back, whatever you need to do. Okay, number 28 is very similar to number 25. It's just going to look a little weird because the percent's so big, but it says in February 1980, you bought some items for $1,300. Between February 1980 and February 2010, inflation caused prices to increase approximately 174.7%. Okay, to the nearest dollar, how much do you need to spend in February 2000 to buy the same products? Okay, so you start with this amount, 1,300. It's increased by 174.7%. So again, this is, even though it looks different because of the percent so big, it's just like a sales tax or a tip problem. Okay, so we start with the amount that we're looking at that we spent in 1980. It's going to increase by 174.7%. So follow the same rules and move twice to the left. 1, 2 to get a decimal. So that's 1.747 times the 1,300. That you have to multiply that first, order operations. That gives you this $2,271.10. You add that to the original 1,300 and you get this $3,571.10. The question was to the nearest dollar, so we round right there. Okay. 29. When you first read it, it could look like a more difficult problem than it is, but they give you a big hit at the end. So it says annual inflation rates have varied in the past from less than 1% to over 18%. That's just going to be, as you're going to see, just information. You're not going to need both those numbers. It says about how many years would it take for the price of a set of goods to double if the average annual inflation rate was 18%. And then the big hint here, that makes it easy, use the rule of 72. So we just did that objective. Rule of 72 can be used when you're looking at doubling the amount that you're saving or investing or whatever a percent is affecting it. So here they just want to know how many years will it take to double. It doesn't matter how much it's at, if you're going from 100 to 200 or 1 million to 2 million. Just how long will it take to double? So remember the rule of 72. You take 72 divided by the interest rate and not converted to a decimal. Just take the number. So we take 72 divided by 18 and it equals 4. And that means in 4 years it will double. Okay. And then the last one. Last one is not really a hard problem, but it's just kind of two problems in one. It's like number 28 or 25, so you just have to do it twice. So it says between July 2003 and July 2004, the average annual inflation rate was approximately 3%. Between July 2004 and July 2005, the inflation rate was approximately 3.2%, so it increased just a little bit. About how much did Mr. Hopkins need to spend in 2005 to buy the same products that sold for $700 in 2003? So we have to take this in steps. So the first step, 2003 to 2004, we have $700 increased by 3% of the $700. So 700 plus 0.03 times 700, we have to multiply here first. Order operations, that gives us 21. Add to the original 700. So in 2004, it would be $721. Now, instead of increasing 3%, increases 3.2%. So we have to go 1, 2, any open spot we put a 0. So we start with 721 plus 0.032 times that 721. Again, you see the same number in those two spots, just like you did up here and some other problems before that. Order operations, say multiply these first, gives you 23.072. Just leave that in your calculator, add to the original 721, and we're going to get $744.07. So that is objective 41. Go into your money workbook to do some practice problems. It starts a new section of practice 41, 42. Again, there's 12 problems here. You don't necessarily need to do all 12. It goes on to the next page, up to problem 96, right here. And then here's the answers. So do some problems, check your answers. It's doing okay. Go on to example or objective number 42 and do the same thing. So, all right, if you have any questions, let me know.